So in the previous module, we looked at the chi-square test, phi, and Kramer's V. And the point of those tests was that you were analyzing the relationship between two categorical variables. And so that could be two nominal variables, one ordinal and one nominal, vice versa. In this module, we're moving up the ladder of the primary scales. And we're switching gears from looking at two categorical variables to one categorical variable and one numeric variable. And so where categorical is an umbrella term that covers both nominal and ordinal, numeric is an umbrella term that covers the upper half of that primary scale set, the interval and ratio level data. And of course, there's a little bit of a fuzzy area, with attitudinal scales, where if you've got a really short attitudinal scale, it really is ordinal. But as we've said multiple times, we treat them as if they're interval. And that allows us to do the kind of tests that we're going to be doing here, at least when you're looking at that scale as the dependent variable. So, I'm talking about the relationship between one categorical and one numeric variable, but it's a little bit more specific than that. It's always where the categorical is kind of looked at as the independent variable and the numeric variable is seen as the dependent variable. And so you're talking about numeric data, you can look at means. And we've only briefly touched on some review of statistics, but you may remember covering measures of central tendency in your statistics class. And so if you're looking at nominal data, the only thing you can look at is the mode, the thing that occurs most frequently. If you're looking at ordinal data, the only thing that really makes sense, you can look at the mode as well, but the measure of central tendency that makes the most sense is the median. And at each level, you can always look back at the earlier measures of central tendency as well. But once you get to interval and ratio level data, the preferred measure of central tendency is the mean. And so when we're comparing different groups in terms of their values, their average values on numeric data, you're looking at means. You're saying, do the means differ? And so that's why even in your SPSS menu, what you're doing mainly are t-tests. In statistical terms, you're using the t-distribution and you're comparing the results of the different t-statistics that are calculated. But SPSS just refers to this as comparing means, because that's really what you're doing. So in this module, we're going to look at three different types of t-tests that are used to compare the means across categories of a categorical variable. And also one f-test. That's the analysis of variance. And that is actually not a t-test, that's an f-test. These tests are always kind of thrown together. If you do any intro stats course, any marketing research course, you'll cover these four tests. So there's a certain affinity of these different types of tests, but it also means that your knowledge of these tests and when to use them, when they're appropriate, it's understanding those little differences of the situations. Why do you use an independent samples t-test instead of a paired samples t-test, and vice versa? And when do you use an analysis of variance instead of an independent samples t-test? But the first stage in all of this really comes down to this idea of when do you do a chi-square versus t-tests? Well, the chi-square is when you're looking at two categorical variables, right? And the t-tests and the analysis of variance are when you're looking at one categorical and one numeric. So we've talked about the levels of measurement, and it's really important that you're able to identify what type of variable you're looking at. And when you have your research question, what kinds of variables are you asking about in your research question? Because it is the level of measurement of the variables that you are examining that determines what the appropriate test is. And so if you do identify your two variables as one numeric and one categorical, and you're looking at the effect of the categorical variable on the numeric variable, that's when you're going to do this stuff. So we'll start with the one sample t-test. And I want you to go back into your data file, and we're going to select cases to filter for, basically everything but 1993. We want to look at the years 1987, 88, and 89. And so we're not looking at the music data, basically, because remember, it's the music data that was asked about in 1993. Okay, and then that will bring us into our one sample t-test. So let me bail out of the PowerPoint, as you've heard me say so many times. And I've got the data file here, and I've still got the variables that I created when I was going through the homework assignment, but we can ignore those really. I'm going to go to data, select cases again. If condition is satisfied, and so I have to change my condition here. It's year equals 1988, or year equals 1989, or year equals 1987. I guess I should put them in order, but it's going to be the same anyway. Okay. The spaces before and after the equal sign don't make a difference, so in case you were wondering. Click continue, and then I will click paste, and you'll still see the syntax from the homework review, but this is the new syntax right here. And so I will run that selection. I'll come back to my data view, and you can see here 1989 is good, 1993 slashed out. That's what we wanted to see. Okay, so we've got the one sample t-test. I'm going to bring up the PowerPoint real quickly again. Now, the one sample t-test, it's always covered along with the other three tests that we're going to talk about in this module. And this video will focus on the one sample t-test. Honestly, I've never used it in the real world. I've never had any reason to use it. And so my perception is that it has somewhat limited utility for commercial marketing research. And that's just because I just haven't been in the situation where I was trying to evaluate whether my sample was significantly different than some specified value. It just wasn't something that came up very much. But that's what this test does. Remember, you have a sample, which gives you a snapshot of a population, based on a subset of that population. You calculate sample statistics with the idea that the sample statistic gives you insight into the value of the population parameter. And so with the one sample t-test, you're basically asking the question, given what information I have in my sample, how likely is it that the true population parameter is equal to some specified value, which SPSS refers to as the test value? And so I'm just going to, I picked a variable that we have in here. We have the number of children in the household. And so you might hypothesize, just kind of off the top of your head, I wonder if the average number of children in a household in the United States in the time period 1987 through 89 was equal to 2. You might go, I think most people have, like 2 kids, give or take a couple, right? And so that's what this test will help you to answer. So to do this, we're going to go to Analyze, Compare Means, and the one sample t-test. So we go to Analyze, Compare Means, one sample t-test. And I want to find the variable child's. So that's going to be my test variable. And then down here, you'll see there's this option to fill in the test value. By default, it's set at 0. So you can test whether the true value is different or the same as 0. In this case, we were estimating 2. We're saying, is it significantly different than 2? And that's it. I click Paste. I go to my syntax. That's what the syntax looks like. If I highlight it and I run the selection, this is what the output looks like. So in this sample, the average number of children was 1.99. That's each respondent answering about his or her household. So that's the mean. Like if you just ran means, what's the mean of children? That's it. You're getting that as part of your one sample t-test output. Now here is the actual test. And we're interpreting the test the same way that we interpreted the statistical significance of chi-square. So you're looking at the sig two-tailed value. If it is 0.05 or below, then that means that there's a statistically significant difference between the test value and the sample statistic. And it'll reiterate for you here, test value equals to 2. So we got an average of 1.99. It is not significantly different than 2. So we cannot conclude that the population parameter is different than 2 based on our sample that has an average of 1.99. So not statistically significant is your takeaway, meaning not different than the test value. That's it. That's really all there is to the one sample t-test. Now, unfortunately, there can be more to the one sample t-test. For the way that I had asked the question, that was it. We were done. Unfortunately, as I say here in the PowerPoint deck, I might have to bring back some potentially bad memories from your stats class. So when we were looking at the chi-square test and the analysis of categorical data, there was no direction because specifically if you're dealing with nominal variables, you can't say higher or lower, right? They're just distributions across the categories. And so either the distributions were significantly different or not. When you're dealing with means, once you have interval level data, you can ask two different types of questions. You can either ask or hypothesize that the two values are the same, which is the same as hypothesizing that they're different. I mean, it's the opposite of it, but it's the same test. If you're checking if they're the same, then you're seeing if they're different. And if you're checking if they're different, you're seeing if, alternatively, if they're the same. But the other type of question you can ask is where you're hypothesizing that one is higher or lower than the other. So in this case, we said the average number of children, the test value would be 2. And we just said, is it significantly different than 2? Or is the population parameter equal to 2? Right? But I could have instead said, I want to test whether the true population value is greater than 2. And in terms of what you enter into SPSS, it's the same test, but the way that you interpret the output is quite different. Rather than simply testing equal versus not equal, one-tailed tests evaluate significantly higher or lower. There's direction specified in the hypothesis. The two-tailed test is just same different, one-tailed higher or lower. And the big difference there is just the way that you ask the question. Okay, so let me show you how you would interpret that here. We'll go back to our example, our one sample t-test. Same output that we were looking at. So if instead of hypothesizing the average number of children equals 2, which is what we did the first time, that's a two-tailed test, it's not significant. We got that 0.746. If we instead hypothesize the average number of children is greater than 2, now, just because of the way we're positioning it, it's now a one-tailed test. And if we look at our sample mean, 1.99, here's kind of the tricky thing. That's it, we're done. We don't look at the significance level. If your hypothesis is that it's greater than 2, but then your sample mean actually comes in lower than 2, the answer is no, it's not significantly greater than 2. You cannot have a significantly greater result if your mean is actually lower, right? It can't be significantly higher if it's actually lower. If you hypothesize that the average number of children was less than 2, and we got the 1.99, so technically it is less than 2, even though, substantively it's basically 2. But 1.99 is less than 2. So then we could test, well, is that significantly less than 2? You will not find a one-tailed significance level in your output. You will only see the sig two-tailed here. So when you are running a one-tailed test, which again is just based on the question that you're asking, you have to take the two-tailed significance and divide it by 2. And so in this case, the sig value for the one-tailed test of whether the average number of children is less than 2 is 0.746 divided by 2. It ends up being equals 0.373, which is still greater than 0.05, so it's still not statistically significant. But that is the process by which you evaluate the output from SPSS to interpret your results of your one sample t-test. So that's just one example. As you're hopefully starting to get familiar with my SPSS training videos, I'm now going to give you an exercise. So again, I have to emphasize, please do not just watch these videos. You're not going to learn what you need to learn by watching it. You really do need to work through them. So work through the exercises, follow along. So exercise 5. And so I'm carrying over the numbering from the earlier modules. Test whether the average age of respondents in the sample is greater than 22. And so the first question, is this a one-tailed or two-tailed test? You don't need to go into SPSS. You should be able to figure that out just from the way that I asked the question. And then what is the significance level of the appropriate test? So we're dealing with one sample t-test. You know it's a one sample t-test, but one-tailed versus two-tailed, and is there anything you need to do with significance level? So at this point, pause the video, take a couple of minutes to run through this, and then when you're done, start it up again. Okay, we're back. And so here's the solution. You should get that the mean age in the sample is 45.23. 45.23 is greater than 22. So we'll look at the significance from the test. This is a one-tailed test, right? Because I said, is it greater than 22? Hence, it's a one-tailed test. The output gives us a sig value of 0.000. So again, that's here. Circling it here with my cursor. So the appropriate significance level, though, because it's a one-tailed test, is actually 0.000 divided by 2, but that's still just going to be 0.000. Like, I mean, that 0.000, at some point, there's probably 0.00006 or something like that. So there would be a slight difference if you carried it out enough decimal places. But for the purposes of the test and determining whether there's a statistically significant difference, 3 decimal places already gets it done, right? So in short, the answer is yes, the average age of respondents in the sample is significantly higher than 22. And real quick, just to revisit it again, here's the SPSS file. It is again under Analyze, Compare Means. We're going to go to one sample t-test. I'm taking the child's variable out. I'm going to replace it with age. And I'm changing my test value to 22. If I hit OK, it'll just run it. But as I've been saying, it's to all our benefits for you to click paste. This is what the syntax looks like. And you can run it. And you should get 45.23 with a sig value of 0.000. In the next video, we will continue on with the independent samples t-test.